Hey guys, welcome to Not So Nerdy channel. So today we are going to understand what is a recursion. So it is a programming technique whereby a function calls itself either directly or indirectly. So you are calling the function again and again till you reach the base case until you get your solution. So here is a short example. You have a function recurse and you are calling the recurse function again in your very same function, and that is why it's a recursive call. And then you have main function, and in that when you call your recurse, it's a function call. Okay, so that is what a recursion is. So direct function call is when you are directly calling the function in the very same function. Okay, it's pretty easy to understand. And indirect is when you have two functions, and in function 1 you are calling function 2, and in function 2 you are calling function 1. So it's an indirect function calling, and that is why you are shifting between function 1 and function 2 calling. Okay, so what are the requirements for sensible recursion? So you need to have a base case, because without a base case, you cannot reach the final solution, and the loop will keep on running. It's going to be infinite, right? So base case is very important for a sensible recursion, and progress is made towards the base case. So suppose you have factorial of a number and you solve using recursion. So you have num5, and your base condition will be if n reaches the 1. So you are having factorial 5, which will return 5 star factorial 4. Then you have factorial 4 returning 4 star factorial 3, then 3 star factorial 2, then 2 star factorial 1. Then when you reach the base condition, when you reach your 1, you return 1. So on returning 1, you keep on storing you go back, you solve, you get the solution. So 2 star 1 2, and then 2 gets stored here. So you get 3 star 2 6, like 4 multiplied by 6 24, and then you finally get your answer as 120. So that is why having a base case is important for recursion. When do we have to use recursion? So recursion is made for solving problems that can be broken down into smaller repetitive problems. You have to repeatedly solve the same thing and get your solution. So it is especially good for working on things that have many possible branches and are too complex for an iterative approach. Okay, so there are two types of recursion: tail recursion, non-tail recursion. Non-tail recursions are also called head recursion. Okay, so what is a tail recursion? The function in which the recursive call is the last statement that is executed by the function. So basically, nothing is left to execute after the recursion call. So you call your function in the end. That's your last statement. So here is a short example to understand. You have a function prints, and if n is less than 0, this is your base case, you return. Otherwise, you print string n, and and the last executed statement is recursive call. So you are again calling your function within the function with n minus 1. So here it will keep on going till your n becomes less than 0. Then it will return. So this is your tail recursion. Non-tail recursion or head recursion is defined as a recursive function in which the first statement is a recursive call and then the other operations are performed. So you call your function in the beginning itself. So you have a function, say n, like a function fun. So if n is greater than 0, you are calling your function first. So first calling the recursive function and then you are printing. So that's the difference between the recursion and tail recursion and non-tail recursion. And there are some benefits and drawbacks of using recursion. Benefits: simple solution that's more elegant and easier to understand, for some problems. So easier to visualize solutions for some people, and certain classes of problems typically require either non-tail recursion to be implemented or some form of backtracking. So I'm going to cover backtracking in my next video. Stay tuned for it. So that is why recursion is important. And drawbacks is like function calls can be costly. It uses up memory and time, obviously, because we are calling the function again and again. Okay. So yeah, I guess that's that. I hope you understood the basic outline of recursion, and we'll have many problems to solve based on this, and you'll get a good overall idea about what it is. Okay. Yeah, so feel free to contact me, reach out to me, ask your doubts. Thank you. Bye bye.